In this video, I will model the process of dimensional analysis using some practice problems. The first question: convert 35 kilograms to grams. In this problem, we want to convert from kilograms to grams. Kilo means 1,000, so 1 kilogram is 1,000 grams. That's the equivalence we need to solve this problem. We're going to stack these equivalent values on top of each other to make conversion factors. So we have two options: kilograms on top, grams on the bottom, and the other way around, grams on top and kilogram on the bottom. We want to convert 35 kilograms, so that's the original value. We will start the calculation with that value and multiply with conversion factors. In order to get rid of kilogram, we want to have kilogram on the bottom of the conversion factor. That way, kilogram will be cancelled out, and gram is the unit that's left. Now, the rest is punching in these numbers in the calculator, but I don't think you even have to use a calculator for this problem. Yeah? 35 times 1,000. The final answer is 35,000 grams. The next question: convert 57 milliliters to liters. We want to convert from milliliters to liters. The equivalence we will use is this: 1 milliliter is equal to 0.001 liters. Milli means 1,000. You can totally use this equivalence, but personally I like using 1,000 milliliters is equal to 1 liter because it's whole numbers. It's just personal preference. If you still haven't memorized the metric prefixes and are having a hard time remembering milli and kilo, which is which, I would just stick with the fact that milli is 0.001. 1 milliliter is equal to 0.001 liters. I just like whole numbers personally, but if that's confusing to you, don't even use it. Anyways, with that equivalence, you get these conversion factors. We're converting 57 milliliters, so we will start the calculation with that number. To get rid of milliliters, we will choose this conversion factor. Milliliters will be cancelled out, and we will have liters left. The rest is punching in the numbers in your calculator. 57 divided by 1,000. The final answer is 0.057 liters. Notice if you decided to use 1 milliliter is equal to 0.001 liters instead of 1,000 milliliters is equal to 1 liter like I did, you still get the same number. 57 times 0.001. So that's 0.057 liters. Next question: convert 45.3 centimeters to millimeters. We want to convert from centimeters to millimeters. If you're familiar with the metric prefixes, you would know that there are 10 millimeters in 1 centimeter. So you can use that as equivalence and come up with these conversion factors. Starting the calculation with 45.3 centimeters, we want to use this conversion factor to get rid of centimeters. What's left is the millimeters. The rest is calculating the numbers. 45.3 times 10. So 453 millimeters is your final answer. If you didn't know that there are 10 millimeters in 1 centimeter, which happens to many of you American students, you can always take step by step, going through the base unit. Meaning you can convert centimeters to meters first. Then you can convert meter to millimeters. The first step, you have this equivalence, so you have these conversion factors. The second step, you have this equivalence, so you have these conversion factors. You start the calculation with the original value, like I did earlier. So you start with 45.3 centimeters. You use this conversion factor to get rid of centimeters. Now you want to get rid of meters. So you use this conversion factor next. What's left will be the millimeters, which is the desired unit. The rest is punching in the numbers in the calculator. 45.3 times 1000 over 100. You can multiply all of the numerators first, then divide that number by all of the denominators multiplied together. Something like this. Next, convert 15.9 millimeters to kilometers. This one is similar to the last one. I would take step by step, going through the base unit meters. So convert from millimeters to meters, then meter to kilometers. Since you are just starting to learn about the dimensional analysis, I would write down all of the conversion factors. But when you get used to it, you probably don't need to write them all down. Here's how I would do it. Starting with 15.9 millimeters, which is the original value, we want to get rid of millimeters and convert it to meters. So what's the relationship? 1 milli is 0.001. Or if you're like me and prefer whole numbers, you can do 1000 millimeters is 1 meter. Either one is fine. Next, we want to convert from meter to kilometers. So we want to get rid of meters, so we put meters on the bottom and kilometers on the top. What's the relationship? 1 kilometer is equal to 1000 meters. The rest is calculating the numbers in the calculator. 15.9 over 1000 times 1000. The final answer is 0.0000159 kilometers. If your calculator says 1.59 e negative 5, that means it is 1.59 times 10 to the negative fifth, which is the same number as 0.0000159. So don't freak out when your calculator does that, okay? Next, This one is a challenging one. Convert 72.4 miles per hour to meters per second. These units, length per time, are units for speed. You know, how far an object moves per certain amount of time, right? So we want to convert from miles per hour to meters per second. How can we do this? Let's take step by step. Let's first focus on the length. Mile, which is an English unit, can be converted to kilometers because the equivalence is given to you in the question. So miles per hour can be converted to kilometers per hour. Then kilometers per hour can be converted to meters per hour because we know the relationship between kilometers and meters. Alright, now let's work on the time. The hour needs to be converted to seconds, right? So let's take step by step. Meter per hour can be converted to meter per minute. Then meters per minute can be converted to meters per second. That's a lot of steps, but we did it. Starting with the original value, 72.4 miles per hour. You know, this means that the original value is a fraction, 72.4 miles over 1 hour. To get rid of miles, we will use miles on the bottom and kilometers on the top. And using this equivalence, 1 mile on the bottom and 1.609 kilometers on the top. The next step, let's get rid of kilometers. Now we have meters as the unit for length, and that's good. Notice that this hour is still here. Now we're going to convert that into seconds. So to get rid of hours, which is on the bottom, we want to choose a conversion factor that has hours on the top. 1 hour on the top and 60 minutes on the bottom. To get rid of minutes, we want to have minutes on the top and seconds on the bottom. The equivalence we will use is 1 minute is equal to 60 seconds. Notice that after canceling out all of the units, what's left is meters per second. The rest is punching in all of the numbers in your calculator. 72.4 times 1.609 times 1000 over 60 times 60. The final answer is 32.4 meters per second. The last question. The difficult part of this question is to identify what we are trying to convert. We're trying to convert 50 grams of iron to milliliters of iron. It's confusing because 50 grams is the mass of iron, but we're trying to convert it to the volume of iron. How does that work? Well, because iron, or any element for that matter, has a specific density. A certain amount of iron will have a specific amount of mass and volume. So 50 grams of iron can be converted to a specific amount of volume. So we are converting grams to milliliters. The equivalence is another hard thing to find in this question, but the density is given to you. The definition of density is how much a substance weighs per unit volume. What does that mean? Well, let's look at the density of iron. 7.86 grams per milliliter. What that means is each milliliter of iron has a mass of 7.86 grams, right? 7.86 grams per 1 milliliter. So you can use that relationship as the equivalence. 7.86 grams of iron is equal to 1 milliliter of iron. So starting the calculation with 50 grams of iron. To get rid of grams, we put 7.86 grams on the bottom and 1 milliliter on the top. That's the conversion factor. Then we can cancel out the grams, and what's left is the volume, milliliters of iron. 6.36 milliliters is the final answer. If you remember the formula for density, which is density is mass over volume, you can plug in these numbers. 7.86 grams per milliliters is equal to 50 grams over volume. You can solve for the volume. And yeah, that's true. And that might be easier. But the point of this activity is to learn the dimension analysis, right? And in fact, the more you get used to using this technique, it actually becomes easier to use the dimensional analysis to solve problems like this one. So keep practicing.